a very warm welcome to Deeksha Karnataka YouTube channel. I hope you all are doing great. I'm Aditi, your physics teacher, and today we are going to see PU2 model question paper number 2. And yes, it's with solutions. We'll solve all the questions from MCQs, fill in the blanks, 2 marker, 3 marker, numericals, derivation, everything. Now, I know you guys know that this paper is very important for your boards. A lot of questions or concepts will come from this paper. So let's start with the solutions. First, subscribe the channel, follow the WhatsApp channel, everything. Okay, let's move on to the first question that says, if a body contains N1 electrons, N1 protons, if a body contains N1 protons and N2 electrons, then the net charge of the body is. Now we know for proton the charge is E, but it's positive, and there are N1 protons, so we'll just multiply N1 with plus E. For electrons it is minus E, and there are total N2 electrons, so if I just add it, I'll get N1 minus N2 into E. Correct? And that is our question number, our option number B. Correct? Let's move on to the next question. Next question says, answer is B. Next question says, the electric potential, read it carefully, electric potential at a point due to point charge varies with distance. How the electric potential varies with distance? We know electric potential is 1 by 4 pi epsilon naught charge by distance, or you can write R. So it's definitely inversely proportional to distance. Correct? So the correct option will be 1 by distance. Correct? Moving on to the next question. Third question says, Kirchhoff's junction rule. What is Kirchhoff's junction rule? Do you remember? If you do, write down in the comment section. Kirchhoff's junction rule is based on the conservation of what? A mass, B momentum, C energy, D charge. So basically, write down in the comment section. So, written down? Okay. Basically, Kirchhoff junction says the amount of current passing from one point entering into a point is equal to the amount of current exiting from that point. So, what is it? Current and charge. So, the conservation is what? It's conservation of charge. My Kirchhoff's junction is based on the conservation of charge. Okay? Okay. And our answer is D. Fourth question. The path traced by a charged particle moving perpendicular to a uniform magnetic field. Let's draw it. There is a charged particle. Let's say this is my charged particle moving perpendicular to a uniform magnetic field. So it's perpendicular to a uniform magnetic field. Correct? This is my charge. So they are asking us the path which is traced by this particular charge. So I know if there is charge, if there is magnetic field, the force on this charge will be perpendicular to both of these. Correct? We know that if my charge is going upward, this is force, this force will pull it towards itself. Correct? And then there is magnetic field, so what will do? It will start, its path will be circular. Correct? Understood? The charged particle which is traveling perpendicular to the direction of magnetic field, its path will become circular. Correct? Because the force is perpendicular to both of these. Okay. Next question. Read it carefully. Very easy though. Based on the magnetic properties, materials are listed in column 1 and values of magnetic susceptibilities are listed in column 2. So this is my column 1 and this is my column 2. Identify the correct match. What do you think will be the correct match? You can write your answers in the comment section with the timestamp, so I'll know who is answering. Okay, so diamagnetic, I know diamagnetic is weak and it repels. Okay, it repels the magnetic field. Correct? We know that. Paramagnetic on the other hand is weak, but it is attracted by the magnetic field. Correct? Ferromagnetic on the other hand, it's strong and it is attracted by the magnetic field. Correct? So for repel here we use negative, and for attraction we are using the term positive. So for diamagnetic, it's small and negative. Correct? Understood? For paramagnetic, it's small and positive. Correct? For ferromagnetic, it's large and positive. So you can just use the trick to eliminate. First is diamagnetic. Diamagnetic is R. So this is wrong. Diamagnetic is R. This is wrong. This is wrong. Oh, we didn't even have to solve the full question. You just know the answer is C, because diamagnetic is small and negative. Correct? Moving on to the next question. It says a straight conductor of length L. Straight conductor of length L is moving with a velocity V. It's moving with a velocity V. Always write down what you are seeing in a question paper. It makes your question a lot of times easier and clearer. Okay? Velocity V in the direction of uniform magnetic field. This conductor is traveling in the direction of uniform magnetic field. Correct? The magnitude of induced EMF. We want to see the magnitude of induced EMF. Okay, across the ends of the conductor. Now, do you know the formula of induced EMF? Of course, ma'am, we know the formula. So, E is basically BLV sine theta. Correct? BLV sine theta. Now, the angle between my conductor, my straight conductor and magnetic field is what? They are in this conductor is traveling in the direction of magnetic field. Correct? It is moving with velocity V in the direction of uniform magnetic field. So that means my theta will be 0 degree. Correct? Understood? And sin theta is what? Sin theta is 0. So this will be BLV 0. Correct? So EMF will be 0. And we know that if a conductor is placed in the direction or moving in the direction of magnetic field, there will be no induced EMF on it. Correct? Because theta is 0. So my option C is correct. Correct? Okay. Next question. It says, okay, very carefully. When alternating voltage is applied to a resistor, when alternating voltage is applied to a resistor, which of the following statement is wrong? Average current over a complete cycle is 0. Average voltage over a complete cycle is 0. C, it says the average power dissipated by the resistor over a complete cycle is 0, and the phase difference between voltage and current is 0. So let's try eliminating us. We know first, if my voltage increases, my current increases simultaneously. So this is correct. Phase difference of voltage and current is same. Now if I have a AC voltage and see alternating voltage we have, correct? If my voltage is alternating, then current is always also alternating, correct? So the average of this current, this is the positive cycle and this is the negative cycle. So this gets cancelled. We know that. So the average current over the whole cycle, my average current will be what? It will be 0, correct? Positive and negative. The average is, the net is 0. So this is also correct. Average voltage, again the voltage graph will also be like this. So this is the positive, this is negative. So the average will be 0. This is correct. What is left? The average power dissipated by the resistor over a complete cycle. If this is my power, correct? And if I write it in the terms of alternating voltage, this will be it. So that means this is V square, and square can never be negative. So this whole term can never be negative, and hence it cannot be 0. If this is my graph, so for power, this will be the graph, correct? We know that this is power. We know the graph. So this will never be 0, and hence the average power dissipated by the resistor over a complete cycle is not 0, correct? So this C is our correct answer. Understood? Okay, let's move on to the next question. 8th question says, which of the following electromagnetic waves are used to kill germs in water purifiers? Very easy. We know it's what? You want to answer in the comment section? Okay, it's ultraviolet rays. UV rays are used to kill germs generally. Okay, okay, and the answer is C. Moving on to the next question, it says the angle of minimum deviation of a prism depends on. Can you tell me the answer? The angle of minimum deviation of a prism depends on refractive index of the material, refractive index of the surrounding medium, refracting angle of the prism. So we know that the minimum deviation, the angle of minimum deviation depends on all these three. It definitely depends on the refractive index of prism, and refractive index of a medium is always relative to the first medium. So first medium is a surrounding medium, that is true, and refractive angle of prism is also plays a role on how much a ray is getting refracted, correct, and diffracted. So D is the correct answer. All these three options are true. Correct? Next question. Image of a real object formed by a simple microscope when the object is placed at a distance less than the focal length. Now I have a simple microscope, and the point that our object is placed between the focal length and that microscope. Okay, so what kind of image will be formed? Can you tell me? Okay, write down in the comment section. I'll give you 1 minute, not 1 minute, 5 seconds. This is easy. So in microscope, okay, wrote down in the comment section. Okay, so in the case of microscope, what kind of lens do we use? We generally use convex lenses because it forms magnified images, and we want in microscope, we definitely want magnified images. So in case of convex lens, the last part, the sixth part, which is the exceptional one, this is the same. The object is placed between focal length and the pole, correct? Or the optical center in case of convex lens. This is my convex lens, this is the optical center. So in that case, my image formed is not real and inverted, it is virtual, erect and magnified, not diminished, virtual, erect and magnified. Understood? Okay, next question, and answer is B. Next question, very easy. Consider the following two statements. We are given two statements. Statement 1 says we do not easily encounter diffraction effects of light in everyday life. Okay. Statement 2 says the wavelength of light is much smaller than the dimensions of most of the obstacles. Okay. Is this correct or not? We know that in generally, like in this room, are you seeing rainbow here? Are you seeing 7 different colors? No, right? So we do not see diffraction in our daily life. Why? Because the reason is exactly correct. Because there are certain particles, dust particles, everything in our atmosphere. All those wavelength of those particles is not comparable to the wavelength of light. These are much smaller. The wavelength of light is much smaller. So, and we know diffraction only happens if the wavelength of light and wavelength of particles is comparable. So in this case, the explanation is true. The answer is correct. Both of these statements are correct, and the statement 2 is the correct reason for the statement 1. Okay. Next question, it says, yes, the process of emission of electrons from a metal. The process of emission of electrons from a metal surface by applying high electric field. High electric field is called as, we know, very easy, ma'am, it's field emission. With the help of, if we are ejecting electrons with the help of electric field, it's called field emission. Okay, correct. Okay, moving on to the next. Where did that go? 13th. For 13th, okay, a good question. Listen carefully. Let K be the kinetic energy. So K is my kinetic energy, U be the potential energy, and E be the total energy. So this will be U plus K, correct? Now they are saying this is revolving around the nucleus of total energy of electron. There is an electron whose kinetic energy is K, potential energy is U, total energy is E. Now that electron is revolving around a nucleus. This is my electron revolving around a nucleus, correct? In hydrogen atom, then which of the following is correct? Now we know, listen to it carefully, we know my electron is revolving around the nucleus, so it is in a bound state, correct? Now it has some kinetic energy, definitely, because it's moving around a nucleus, so kinetic energy cannot be negative, it's greater than 0, definitely, because it's moving. Now since this electron is in what? It's in bound state, correct? And in bound state we know it has a negative potential energy. What? A negative potential energy, correct? Now what about total energy, ma'am? Kinetic energy is positive, potential energy is negative. The whole net result of this whole process is what? The electron is still bound, correct? That means if electron was not bound, then kinetic energy would have been more, right? But my electron is in a bound system. This is a bound system. So what does that mean? That means my potential energy is more than kinetic energy, and hence this is negative, this is positive. So if negative term is more, so this whole is also negative. So that means E is less than 0. Correct? Understood? So the right one will be K greater than 0. In every case K is greater than 0, in D it's not. So we'll eliminate that. U is less than 0. So in only this case, in only B case, this is greater than 0, greater than 0. So that's wrong. K should be greater than 0. U should be less than 0 in a bound state, and hence total energy will be less than 0. Correct? Okay. Moving on to the next question. 14th. Among the following, which set of nuclei are isotones? Now we know what is isotone. Isotone is something which has different number of neutrons. Correct? In which case the neutrons are different? 12 minus 6 and 13 minus 6. Sorry, neutrons are same. Isotones are something in which neutrons are same. Number of neutrons are same. So this, it has different neutrons. Correct? This, however, 2 minus 1 is 1, and here 3 minus 2 is also 1. This is same. So this can be true. In all other cases, the number of neutrons are what? It's different. Correct? And isotones are the ones in which number of neutrons are same. So our answer will be what? It's B. Correct? Our answer will be B. Okay. Moving on to the next question. Okay, this is also a good question. Carbon, silicon and germanium have 4 valence electrons each. We know that they are characterized by valence and conduction bands separated by energy band gap. So this is my conduction band and this is my valence band, and this is called my energy gap. Correct? Energy band gap equal to, and it's for carbon it's EgC, for silicon Eg silicon, and Eg germanium for germanium. So which of these comparisons for energy band gap is true? The energy band gap of carbon is more, or silicon is more, or germanium is more. So we know, ma'am, this is very easy. Carbon, B is definitely the right answer. The energy band gap of carbon is more than the, not the energy band gap. Let's say we are coming down. So carbon, silicon, germanium, correct? So the size of nucleus, so the size of these atoms, these shells are increasing, correct? So carbon can easily bound its electrons, and then compared to silicon, it can not easily bound that electrons with much force, and then comes germanium. So carbon, silicon, germanium. Correct? As we go down, their energy band gap increases as the size of the shells around the nucleus increases, and the last valence electrons are not as tightly bound as they were in carbon. Correct? So it's more difficult to take out electrons from carbon than silicon than germanium. That's my answer, which is option B. Correct? Understood? Moving on to the next question. Oh, we have fill in the blanks now. Very easy, I guess. Okay, we are even given the fill in the options for these, but Be very careful. A current carrying dash is equivalent to a bar magnet. Now we studied, even in 10th class, we studied that solenoid. If there is a solenoid, it has the same kind of magnetic field as a bar magnet. So that is my solenoid. Correct? The device which converts mechanical energy into electrical energy. Now, I don't know if you guys use generators anymore in your houses, but we have those generators which you put fuel or diesel in, and it gives you energy in return. So what it is doing? It is converting mechanical energy, because we used mechanical energy to like power that or start that. So it converts mechanical energy into the electrical energy, that is AC generator. Okay. 18th question says the device that varies alternating voltage is called, the device that varies alternate voltage is, definitely ma'am, we know it's very easy, it's transformer. Correct? 19th, the phenomena of light which confirms the transfer nature of light waves is what? It is nothing but polarization. Okay. 20th question, during photoelectric emission, the number of photoelectrons emitted per second is directly proportional to the what? The number of electrons. Very careful, the number of. If the more, and they can ask you in which case more energy of electrons will emit, in which case more number of electrons will emit. Okay, so be very careful while answering this. This is what? This is intensity. The more the coming light is, the more light rays are coming, the more electrons will be ejected. That means the more intensity of light is coming, and hence more electrons are being ejected. Correct? Okay, let's move on to the next question. Sketch the electric field lines of a positive point charge and an electric dipole. Very easy. We learnt this. This was one of the initial topics of your 12th, right? For plus charge, we know that its electric field goes outwards. The electric field lines goes outwards. Correct? This is correct. And for dipole, and we know for minus q, the electric field lines are towards the charge, towards the negative charge. So in case of a dipole, where we have pair of charges, which is one is plus q, one is minus q, so electric field lines will go out from this and then go in this. So this will be my trajectory and this will be my trajectory. Correct? So this will be the path of electric field lines. It's going out, correct, and it's coming into the negative charge. Very easy. Correct? Okay, moving on to the next 22nd question. I gave you the answer already. Okay, what are polar molecules? So the molecules which does not have the positive and the negative charges, their positive and negative centers should not coincide, those kind of molecules are called polar molecules. The molecules in which the center of positive and negative charges does not coincide is called polar molecules. If this is my water molecule, correct, then the center of positive is here and the center of negative is here. Correct? So the center of positive and negative charges is not coinciding, hence these are called polar molecules. So it can be HCl, H2O. Okay? Next question. I did use some animation effect so that the answer will not be visible. Okay, state and explain Ohm's law. We very well know, we studied this in 10th class. Ohm's law is that in an electrical conductor, when current is flowing, it will be directly proportional to the potential difference across the two ends of a conductor. This is my conductor. If current is flowing through it, then it will be directly proportional to the potential difference between the two ends of this conductor, but provided that all the physical quantities, especially temperature, remains constant. Correct? Ohm's law states that electric current flowing through a conductor is directly proportional to the potential difference across its end, provided the physical conditions such as temperature remains constant. Correct? That's it. So this is just V directly proportional to I, V equals to I R. Correct? Moving on to the next question. What is happening? A current loop of magnetic dipole. This is a very easy numerical. A current loop of magnetic dipole moment 10 ampere meter square is given. So M, that is magnetic dipole moment, is 10 ampere meter square is given to us in the question. Write it down. Everything that is given to you in the numerical, write it down so it will give you a clarity. Is freely suspended in a uniform magnetic field. So we are also given with uniform magnetic field of 5 into 10 raised to the minus 3 Tesla. This is a 2-marker question. Now, and its plane is present in the direction of magnetic field. Its plane is present. See, if this is my magnetic field, so this plane is also present in the direction of this magnetic field. Right? Then what will happen? The area vector or the B will be perpendicular. The magnetic moment, the magnetic dipole moment will be perpendicular to this plane. Correct? And this will be M, and this is my B. Correct? So the angle between magnetic dipole moment and my magnetic field is what? It is 90 degree. Correct? Understood this diagram? This is my magnetic field and this is my what? This is a plane that is present in the direction of magnetic field. So this is a plane and this is the magnetic field. So these are parallel. So magnetic moment is always perpendicular to the plane of what is this? Yeah, this is the magnetic moment will be perpendicular to the plane. So between magnetic moment and magnetic field, the angle will be 90 degree. And we know we want to calculate torque. So torque is basically what? M cross B, correct? Which will be MB sine theta, MB sine theta. Now theta is what? It's given as 90 degrees. So sine 90 is 1, which will just be M into B. And M is given as 10 and B is given as 5 into 10 raised to the power 3. So which will be 5 into 10 raised to the power minus 2. Correct? Understood? Okay, let's move on to the next question. Why am I getting answers to all this? Okay, now it will be good. Why I was stressing so much on not seeing the answers for you? Because I want you to read the question properly and not dive into the answers. Okay, so let's read the question properly first, which says, mention the two factors on which self-inductance of a solenoid depends. So we know, ma'am, basically the formula of self-inductance is what? It is mu naught n square A divided by L. So what are the factors? It is permeability, okay, it is number of turns, area and length of the solenoid. This is permeability. Let's see the answer. L mu naught n square A by L. Correct? So the factors are definitely number of turns. More the number of turns will be, more will be the magnetic flux and hence higher self-inductance. Correct? Then permeability of the core material. The material which we use, which we wrap the copper wire around is called core. So permeability of that core material is higher, that means higher self-inductance. And then area increases, smaller the length, more will be the self-inductance. Correct? Let's move on to the next question, 26th. It says, what is displacement current? Write the mathematical form of Ampere-Maxwell law. So displacement current, firstly we just had conduction current. Now conduction current was going good. What was the need of displacement current? How did we find the displacement current? So when we saw, when the capacitor was charging, why it was charging, why it had a current in it, that was the displacement current. Why it happened? Because of the change in electric field. Between the capacitor, the electric field was changing. Displacement current is the current associated with the changing electric field in a region such as between the plates of a capacitor. Now we know displacement current is basically epsilon naught d phi E by dt. Correct? And where phi is our flux. Okay, the mathematical form of Ampere-Maxwell law says that my magnetic field over a closed surface, or magnetic field intensity in a closed surface, this is the closed integral, so over a closed surface is equal to the current. This is conduction current, okay, and this is my displacement current. So the magnetic field is equal to both, is because of both conduction current and displacement current, hence it's mu naught I plus epsilon naught d phi by dt, correct? Okay, this is okay, correct. Let's move on to the next question. 26th, define impact parameter. And what is the angle of scattering for minimum impact parameter? What is impact parameter? Say this is my gold foil, whatever, nucleus, okay? This is my alpha particle which we are throwing it towards the nucleus. Now this line, the line around which this, on which, the path on which this alpha particle is traveling, this is, we depict it with this line. Now around the nucleus, from the center of the nucleus, this is our, let's say, kind of principal axis, main axis. So this perpendicular distance between what? Between the path of alpha particle and the principal axis, this is called B, which is what? Which is our impact parameter, correct? Let's see if we answered it correctly. Impact parameter is the perpendicular distance. This is alpha, this is principal axis, let's say. This is the perpendicular distance between the initial direction of alpha particle, correct? Initial direction of alpha particle and the central line through the nucleus of the target atom. Correct, that's what I told you. So this is what impact parameter is. Now if impact parameter is minimum, if this B is almost equal to 0, so this is where my alpha particle is traveling, correct? And here is the nucleus. So if it comes there in almost very close to nucleus, see, if the alpha particle is here, it will deflect like this. But if it is very close to nucleus, it will deflect right back, which is angle 180 degree. When the impact parameter is minimum, the alpha particle moves directly towards the nucleus. So angle of scattering is 180 degree, and this means alpha particle is deflected straight back, correct? Okay, moving on to the next question. Give any two differences between intrinsic and extrinsic semiconductors. Let's just see its answer. Okay, intrinsic, we know it's a pure semiconductor without any doping. Extrinsic, on the other hand, is due to the small amount of doping, correct? This has low electrical conductivity because the number of electrons, number of free electrons are less, so it has low electrical conductivity. On the other hand, has much higher conductivity due to increased electrons or charge carriers. This is of two type, which is P type and N type. Correct? Move on to the next question. Okay. We are already at 29. Okay. 29th question says, give Coulomb's law in vector form and explain the terms and tell the SI unit of charge. So Coulomb law we know, that is 1 by 4 pi epsilon naught Q1 Q2 by R square. But we have to define it in vector form, okay? So if this is my coordinates, this is my first charge, this is my second charge, Q1, Q2. This is R1, correct? This is R2, this is origin, correct? And this is the vector. This is the distance between Q1 and Q2. We can name it as R21. Correct? And this is a vector. So what will be now the vector form? That will be 1 by 4 pi epsilon naught Q1 Q2 is correct, distance is correct, R square, but it will be R21 cap, and this will be equal to F21, that is force on second particle due to the first particle. Force on second particle due to the first particle. Correct? Let's see the answer. That is for 2-point charges Q1 and Q2 separated by a distance R. That's what we did. Q1, Q2 separated by a distance R. Okay, the electrostatic forces on Q2 due to Q1, on Q2 due to Q1, which will be just, you have to write R21 cap. Okay, this is a unit vector because we already take the magnitude. This is just for the direction. Okay, so what they are asking is also explain the terms. So F21 is force on charge Q2 due to Q1, correct? 1 by 4 by epsilon naught is constant. Q1, Q2 are the magnitudes of charge. R is distance between these charges. R21 is unit vector. It's unit vector, not just a vector, unit vector towards Q2 due to Q1, giving the direction of force. That's what I told you. Okay, and one thing more you can write which will make you seem very intelligent is if Q1, Q2 is greater than 0, that means both are positive. Both are positive, then only it will be greater than 0, or both are negative, then only it will be greater than 0. If Q1, Q2, it's repulsive. If Q1, Q2 greater than 0, if only one is negative and one is positive, then Q1 into Q2, positive multiplying negative will be negative, that is less than 0, so that will be attractive force, correct? Okay, move on to the next question. Oh, we still have to define define the SI unit of charge. So SI unit of the charge is Coulomb, simply, but we can also define that 1 Coulomb is the amount of charge. This was our Q1 Q2 divided by R square. So the 1 Coulomb is the amount of charge that when placed in vacuum. Why we wrote vacuum? Because we don't want other quantities like air and other things and other particles and charges in our atmosphere to influence our system. Okay, when placed in vacuum at a distance of 1 meter, this is 1 meter from an equal charge, so these two charges are equal. Okay, and they are placed Q1, Q2, they are placed 1 meter apart, then only they will experience a force which is 9 into 10 raised to power 9 Newton. Makes sense, correct? And we also know from 10th that 1 Coulomb of charge flows, the charge flowing in 1 second when current is 1 ampere. Okay, but you need to write this because you are in PU2 now. Okay, mention any 3 important results regarding electrostatics of conductor. There is a conductor. Now, do you remember what are the properties of charges on conductor? First one I remember is that the whole charge, all the charge of conductor, be it positive, negative, it resides on the surface of conductor. Even if my conductor is hollow or it's filled a sphere, the whole charge resides on the surface of conductor. Net electric field, if the whole charge is on the conductor, so net electric field inside the conductor will be what? It's 0. Correct? And the third one is that electric flux, when electric field coming out or electric flux from the conductor is always perpendicular to the surface of conductor. Correct? Let's read the answer. Electric field inside the conductor is 0. Correct? Electrostatic equilibrium, charges stop moving, so the electric field within the conductor becomes 0. Correct? Then excess charge resides only on the surface of a conductor. Charges, we know charges move as far from each other as possible, so they settle on the outer surface. And then third is electric field is always perpendicular to the surface of a charged conductor. Correct? This is the exact definition that you can write. You can take screenshots. If it were not perpendicular, it will produce a tangential component. If it was not perpendicular, it will produce a tangential component. Correct? And charges would start moving, contradicting electrostatic equilibrium. Correct? Okay. 31st question is what is Lorentz force? This is a very important and very talked about topic in your classes, right? Write the expression representing the force and explain the terms. So let's see the answer. Lorentz force is actually the total force experienced by a charged particle. See, there is a charged particle and it is placed inside a magnetic field and there is also an electric field. Although we do know because of magnetic field charges move, current is produced, and if current is produced, electric field is produced and all that stuff. So if a charged particle is placed inside under the influence of magnetic field as well as electric field, then there is a force that acts on that particle which is called Lorentz force. Mathematically it is given by QE, which is due to the electric field, and QV cross B, which is due to the magnetic field. Correct? For defining the terms, we know this is Lorentz force, this is my magnitude of the electric charge, and then V is the velocity of charged particle, B is the magnetic field intensity, and E is electric field intensity, and V cross B is the cross product of the velocity and magnetic field of force of direction. Correct? Can we move on to the next question? Okay. State and explain Gauss's law in magnetism and give its significance. Now, Gauss's law in magnetism you might remember, but significance is very important. Gauss's law in magnetism states that the net flux, that magnetic flux through any closed surface is always zero. There is a closed surface and the net magnetic flux of that surface through that surface will always be zero. That means B dot dA with closed integral. This is a very important derivation even in further if you pursue physics. This is one of the most main definitions of electrostatics, electromagnetism and everything. So the magnetic flux through any closed surface is always zero. Okay, so what is the significance? This signifies that magnetic monopoles does not exist. Correct? Because the magnetic lines are always closed. If they go out, they also come back, hence cancelling. Hence, the total flux is zero. However, magnetic field lines going out, they are coming back as well. So, total flux is zero. So, this confirms non-existence of magnetic monopoles, and there are magnetic field lines are continuous loops. We know from Bachpan. Third, helps in understanding magnetic field behavior. If we know that flux is zero, it will help us to understand how my magnetic field lines, how magnetic flux and all that stuff is behaving in a particular material of a particular shape. Correct? And then fourth is foundation of Maxwell's equation. It is one of the 4 Maxwell equation and is very essential because it depicts a major thing that says that magnetic monopoles does not exist. It kind of proves that point. Okay, so it is very, very important. Okay, now for the 33rd question, let's see, derive the expression for the magnetic energy stored in a coil. So we want to calculate magnetic energy. Now magnetic energy we can calculate from the work done. Correct? Now if this is my coil, correct, this is the coil, we need to calculate energy. So can I write P power equals to rate change of work? Correct? Just remember the starting of a derivation. Correct? Now P I know is also voltage into current, which I can write EMF into current, and E on the other hand for inductor I know is L di divided by dt. So power is what? L di divided by dt into I. Correct? This is my power. So can I write power as L into I di divided by dt equals to dw divided by dt. Correct? If dt goes this way, this is L di by dt into dt. So this will cancel out, and while integrating both sides, L comes out. This will be I into di, and this is the integration of dw, which will be just w. Correct? And the integration of this will be what? L into I square by 2. Correct? And this is w. So which is our expression? W can be written as u, and this is half Li square. Correct? This is exactly what we needed to find, half Li square. Correct? Let's move on to the next question, which says, give the Cartesian sign convention used to measure distances and height in a spherical mirror. So just we can see if this is my mirror and this is my principal axis, I know that height above the principal axis is taken as positive. Correct? So, and object is always placed above the principal axis. So, HO, height of object is always positive. Height of image will be positive for virtual and erect, and it will be negative for real and inverted in case of mirrors. Correct? Done with heights. Then with distance, we know U is always placed on the left hand side of the mirror. So, that will be negative left hand side of the mirror. V is equal to negative for left hand side, that is what? For real and inverted images. In case of mirror, remember, for lenses it's different. And V is positive for right hand side, correct, for virtual and erect images. Done? That easy? Correct? This is my mirror, this is left hand side, right hand side, it will be positive, negative, this will be positive, this will be negative. Correct? Understood? Very easy. Next question says, write any three properties of photon. Now, photon we know is a particle that we define light with. Okay, it's a particle basically. So, photon what has? Photon has zero rest mass. It does not have any rest mass when it is at rest. That is what rest mass is. So, it's zero. Its energy is h into nu. This is h into nu. Frequency and Planck's constant. And momentum is h by lambda. Correct? Then photon travels with speed of light. With the speed of light, we mention that photon is a particle of light, kind of, correct? So, it travels with 3 into 10 raised to power 8 meter per second. And the third is, photon has no charge, so it is not deflected by either electric or magnetic fields. Correct? If light is traveling, it won't be affected by electric and magnetic fields. Correct? 36th question. Moving on to the next question, the 36th question says, I've written some things down for you, let's read it. Calculate the binding energy of an alpha particle. We need to calculate the binding energy of what? Alpha particle in MeV from the following data. So, we are given the mass of alpha particle is 4.0026 U, mass of neutron 1.008662, mass of proton as 1.007825. Now, we clearly know we can calculate this with the help of what? Mass defect. Do you remember the formula of mass defect? It's very important, and it says that Z into mass of proton plus atomic minus proton into mass of neutron minus the original mass of our alpha particle, which is given. Correct? So, we can just fill these values here. If you see, alpha particle is what? It's helium 4, 2. So, Z equals to 2 and A will be 4. Correct? So, Z will be 2 into mass of proton, which is given to us, this one, 1.007825 plus 4 minus 2 is 2 into what? Mass of neutron 1.008662, then minus the original mass, which is 4.00260 unit U. Okay? Correct? Understood? And now I know you guys can use calculators, right? So, just use the calculator for this one. It will be really easy for you. So, the calculation that we'll get after this, delta M or the mass defect will be 0.0303744. Correct? Now, I have mass defect. I just want to calculate the binding energy. Do not finish your answer here. Remember, you have to calculate the binding energy. Now, how can I calculate the binding energy? Binding energy's formula is just binding energy equals to delta M into the energy of 1 atomic unit, correct? 1 atomic unit, energy of 1 atomic unit. That is what? This is, you need to remember, 931.5 MeV, correct? And delta M is this same. You can put this here. So your binding energy will come out to be, the final answer will be 28.29 mega electron volt. It should be in what? It should be in mega electron volt, correct? Let's move on to the next question, can we? Okay. The next question says, yes, now we are on to the some derivations or those kind of long answer type questions which are 5 marks. So, using Gauss law, they are asking us to use Gauss law, arrive at the expression of electric field at a point outside the charged spherical conducting shell. We are given a charged spherical conducting shell. So let's make that first. This is, let's say, my charged spherical conducting shell. Now, since it's a shell, so all the charges will reside on its surface. True? We know that. Correct. So now they are saying, since the charge is on the surface, now they are saying that we have to calculate electric field at a point outside this shell. So let me take this point outside the shell. Okay, is it visible? Okay, this point outside the shell. This is my center. If I take, so if I join this, and now we have to use Gauss law. And what is the first step that we do while using Gauss law? Can you wait, there is a reflection here, right? Okay, now it's okay, right? Yeah. So we have to make a Gaussian surface around this. Okay, so through this point we'll make a Gaussian surface that will extend all the way towards this, towards our conducting shell, correct? Now we'll use what? Gauss law. So according to Gauss law, E dot dA, electric field over a closed surface, is equal to Q by epsilon naught. Now we have E and dA. We need to figure out what E and dA is. So I know what the first step is. I'll take an area element, small area element over this point, correct? This is the area element, and I know the area vector will be perpendicularly outwards, correct? But I know that the electric field on this point due to this shell will also be perpendicularly outwards, correct? So theta between E and dA, will be what? Theta will be 0 degree, correct? So can I now write this as E dot dA, E dA cos theta, correct, equals to Q by epsilon naught. Now E, this is what? Cos 0 is 1, correct? Cos 0 is 1. So this will just be E dA equals to Q by epsilon naught. Since this E is constant over that whole Gaussian surface, it does not change on that, so we can take the E out. dA, closed integral over dA, Q by epsilon naught. So E will just be this, and now area of that spherical surface will be what? It will be 4 pi r square, correct? 4 pi r square equals to Q by epsilon naught. Now remember, r is the distance between this point and the center, correct? And let's say this is of radius capital R, correct? You have to write everything over it, okay? Consider a spherical conducting shell, all the charge will reside over its surface. Then we'll make a Gaussian surface, the area vector will be perpendicularly outwards, electric field will be perpendicularly outwards, and it's of radius capital R. The distance of this point from the center is small r. You have to write everything down, okay? Because this is a 5 marks question, the derivation is not that big. Okay, so what you need to find? Electric field. So that will be just Q by epsilon naught into 1 by 4 pi r square. Correct? That is my electric field. I'm done with this. Now what we need to find, they asked us also write the expression of electric field at a point on the surface. What? On the surface of the same charged spherical shell. So on the surface, if my point is here, its distance will become capital R. So what I'll do, instead of this small r, I'll just write on the surface. On the surface, the electric field will be what? 1 by 4 pi epsilon naught q by capital R square. Correct? Q by capital R square, and this is my final expression. Correct? Can we move on to the next one? Okay, one more thing you can see is inside the sphere. If they've asked you inside the conducting sphere, so there is no charge, all the charge is on the surface, so inside the E will be 0, where inside the spherical conducting shell. Correct? Let's move on to the next question. It says again, expression. Obtain the expression for equivalent EMF. You need to find equivalent EMF and equivalent internal resistance of two cells. We are given two cells of different EMF and different internal resistances connected in series. Read it carefully. This is connected in series. So let's make the diagram. This is, let's say, my two cells, okay, which are connected in series, and correct. Now they have, okay, so let's say this is E1 and this is E2. Also you have to write again. Consider two cells connected in series. The first has EMF as E1, second has internal EMF or EMF as E2. The first has internal resistance as R1, the second has internal resistance as R2. Okay, now since this is a series connection, so current will remain same. Correct? Current will remain same in the whole circuit, but the voltage will be different. Across first, the voltage will be V1, and across second, the voltage will be V2, because we know in series voltage divides. So I know the formula of voltage now. This is EMF minus I into internal resistance. Correct? So for V1, can I write E1 minus current is same R1. Correct? Till here, is it correct? Okay, V2 will be E2 minus I into R2. Great. Now, if I add those, I just have to see equivalent resistance. Equivalent, for that, the whole voltage will be what? V1 plus V2. So, if I add these two, V1 plus V2, this will be what? E1 plus E2. Okay, minus I R1 plus R2. Correct? Now equivalent resistance. If V equivalent equals to V1 plus V2, correct? So this will also we can also write this as E equivalent minus I is same, R equivalent, correct? And V1 plus V2 came out to be this whole expression, which is what? E1 plus E2 minus I R1 plus R2. Just from here, if I compare these terms, I'll get E equivalent. On comparing these terms, we'll get E equivalent as E1 plus E2 and R equivalent as R1 plus R2. Correct? That's what we had to find, and that's where we complete our question. That's it. Okay? Okay. Moving on to the next question, it says, derive the expression for force per unit length. We need to find force per unit length on two infinitely long straight parallel conductors carrying currents, and hence define ampere. Let's make this diagram. We have two infinitely long straight parallel conductors. Okay, so this is my two infinitely long straight parallel conductors. This is infinity till infinity, goes till infinity, this goes till infinity. Correct? Let's say for now the current is in both the wires the current is in same direction, correct? Now we are using, what we'll do, we have to find the force, correct? So for force on a current carrying conductor, we also quite need, we know the Fleming left hand rule. So we need force, we have current, we will find force, but we need magnetic field as well. And we have current. So by using right hand thumb rule, we can find the direction of magnetic field, correct? See how you link it, you have to find force. Force can be found with the help of Fleming left hand rule. For Fleming left hand rule, we need B, and B can be found with the help of right hand thumb rule, correct? Okay, so the current is upwards. Let's say this is first and this is 2. So I1 is upwards, I2 is also upward. If using my right hand thumb rule, this is the direction of current. So if I curl, the magnetic field here is inside, correct? Inside the plane of board, correct? So can I, this is my current, can I define or express B as inside like this? This is 90, correct? This is 90 degree. For the same, this is current in upward direction and this is my magnetic field. On this side, the magnetic field is coming out. Here it's going in, here it's going out, correct? So here at this point, my magnetic field is coming out of the plane of board, correct? So if this is my I, this will be my magnetic field, correct? And this is also 90 degree. Now this magnetic field is because of this conductor, correct? So this will be B2, and this magnetic field will be due to this conductor, so this will be B1, correct? Understood the question? Everything? Okay. Now due to straight conductor, straight wire, we know the magnetic field is mu naught I by 2 pi r, correct? Correct, right? Let's say this distance is what? This distance is D. They are D distance apart. So on first wire, what will be the magnetic field? B1 will be what? Okay, B1 will be B2, sorry, on B2, on first wire, it will be B2 because of second wire. On first wire, magnetic force or magnetic field will be happening due to the second wire. So because of second wire, B2 will be what? Mu naught I2 divided by 2 pi into D, correct? For second wire, B2 will be due to I1, so that will be mu naught I1 divided by 2 pi, distance is same, so that is D, correct? Now we need to find force. So force on, let's say 2 due to 1 will be what? Force on 2 due to 1. Now we know it is ILB sine theta, correct? Since what we saw, theta was 90 degree, so this will be what? ILP. But we need to see one thing. This is force on 2 due to 1, correct? On 2, force on 2 is because of B1 and I2. So I'll take I2 and B1 here, correct? Here also I2, B1. If I just put in the value from here, this will be I2L and B1 will be again this, this is B1. So B1 will be mu naught I1 into mu naught divided by 2 pi D, correct? So this will come out to be mu naught I1 into I2 into L divided by 2 pi D, correct? Correct? Now we need to find F by L. So can I just write it? F by L equals to mu naught I1 I2 divided by 2 pi D, correct? Similarly, for force on 1 due to 2 will be what? I on 1, L, B of 2, because on first conductor, on first wire, the magnetic field, the force is due to the second wire, due to the magnetic field of second wire, correct? So this will be I1 L mu naught I2 divided by 2 pi d. Correct? So F12 will be mu naught I1 I2 divided by 2 pi d, and since we have to find by L, so this will be F by L. Correct? Understood? It was that easy. Did you see? What we saw, we need to understand how to start the question. We know that definitely there is a current flowing in this because it's a current carrying straight conductor, so current is flowing. So if current is flowing and I need to find force, how will I go through that path? Okay, so I am given with current, I need to find force. With current, for force I need Fleming left hand rule. Correct? For Fleming left hand rule, I need force, I need current, and I need magnetic field. Direction of magnetic field. Correct? Now current I have, force I have to find, B I need to find. Correct? How can I find B when I am given I? When I am given I and I need to find B, that I can do with right hand thumb rule. Correct? Right hand thumb rule. Correct? Can we move to the next question? This is it. Okay. Next question says, two coherent waves of same amplitude. We have same amplitude and constant phase difference undergo interference. Obtain an expression for resultant displacement. So normal displacement, how do we write? We write there is amplitude and since it's coherent, it will be sine and it will be omega t basically, but here it has phase difference. So what we have two coherent waves. Correct? Two coherent waves, let's say of amplitude A. Correct? This is my amplitude. Now if I have to write a displacement for each one of these, so let's say y1 will be A amplitude, sine and omega t. Correct? Now the second and the first has a phase difference of, let's say 5. Fine. With phase difference as phi. Correct? So the second displacement of second will be A sine omega t, since the amplitude is same but it has a phase difference of phi. Correct? Understood this till here? Now just resultant displacement, you just need to add these two, y1 plus y2, and this will be A sine omega t plus A sine omega t plus phi. Correct? Now can I use a trigonometric function on this, that A common, and inside see sine plus sine will be 2 sine cos. Correct? So here what we'll do is 2 sine, first we'll add that. Correct? Okay. Sine A plus sine B is what? 2 sine A plus B by 2. A plus B by 2 and cos A minus B by 2. Correct? This is my trigonometric formula. We all know that. Can I apply that here? It says 2 sine A plus B by 2. That means omega t plus phi by 2. So omega t plus phi divided by 2. And then I have cos. Cos here will be omega t. So since we don't need, okay, you can do in any way because cos minus theta is then generally equal to cos theta. So however you subtract this, you will get the same answer. So we can just write omega t plus phi minus omega t divided by 2. Correct? Divided by 2. Correct? Understood? Next, you just have to solve this. Just 2 sine, this will be omega t plus phi by 2. Correct? And cos phi by 2. Correct? This will get cancelled. Okay? So this is my whole expression of resultant displacement. And what will be, since this is omega t is in the term of sine. So I can write y equals to 2a cos phi by 2 sine omega t plus phi by 2. Correct? So my amplitude will be what? My amplitude will be this single term. Amplitude will be 2a cos phi by 2. Correct? Understood the question? If you have any doubt, you can comment down. Okay, I'll see and I'll try to answer every one of you. Okay, okay. Next question. Are we done with this question? Okay. Mention 2 uses of Polaroids. So Polaroids are basically used in our shades, the goggles you use, not the normal ones, but the Polaroids, what they do, they decrease the intensity, right? So very expensive or very good quality of goggles use actual Polaroids, and then our car windows and some LCDs, photographic cameras, they also use Polaroids. Correct? Okay. Next question. 41. What is meant by rectification? If you know, comment down. I'm giving you 5 seconds. Pause this video, write down the answer and come back and look at the answer. Okay? Be honest here. We are working with honesty. You need to score marks. I want you to score marks. Okay? So we are on the same page. Comment down what is rectification. Okay? Okay. Let's see. What is rectification? The process of converting AC into DC. What? The process of converting alternating current into direct current is called rectification. Now, what is full wave rectifier? Full wave rectifier is nothing but it converts the entire cycle of AC. See, this is my AC. It will convert the entire cycle of AC signal into DC1. Correct? Into DC1. Understood? Let's see what they are asking. We need explain the working of a PN junction diode as a full wave rectifier with the help of relevant circuit diagram. So let's make the circuit diagram first. We know actually you just need to, you understood what is the working is, right? But also you need to remember it. So what we have? We have an inductor which is our primary coil, and this is center tapped, and then we have another secondary coil. Correct? The number of turns in primary coil is a bit more than secondary coil, we know that. Then we have 2 diodes here, PN junction diodes here. Okay, both are in the same direction, and we have one resistance here, and through which we measure our output. Correct? Understood? We are given us, and this is our sinusoidal voltage here, because it converts AC into DC. So we need to give a sinusoidal VC into it. Okay? So this is my input. Let's say this is my input. Correct? This is my AC input. So what will be the working? Let's see the working. It consists of a transformer. It is a transformer in which input is given to the primary coil. This is my primary coil. Input is given into the primary coil. Correct? The secondary coil is then connected to 2 diodes. This is D1, and this secondary coil is connected to 2 diodes, D1 and D2, and load resistance RL across which output is taken. This is RL. Correct? Now what is the working? During the positive half cycle, if this positive half cycle is going into these diodes, okay, so D1 will be what? D1 will be forward biased. Correct? So this is positive, then this will be negative. This will be forward biased, this will be reverse biased. So in this case, what will happen? Through this current will flow, there will be some voltage across RL, and will get the output. What is forward bias? D2 is reverse bias, therefore there is a flow of current due to D1, hence we get an output. If we switch the cycle during negative cycle, this will be negative, this will be positive, this will get reverse biased, D2 will get forward biased. During negative cycle, D1 is reverse biased and D2 is forward biased. Therefore, there is a flow of current in the circuit due to, now D2 here, due to D2, hence we get the output. That's it. That we defined what a rectification is, what is a full wave rectifier, its circuit diagram, its construction, this is its construction, correct, and its working. Done. And you need to make with an input output waveforms. So this will be my input, correct, this will be my input waveform, correct, this is AC. If I draw this same what will be its output? Since it's a full wave rectifier, what you have to do, all the cycles, they will convert it to full into the positive cycle, correct? This was positive, negative, positive. These all are now positive, correct? Understood? Any doubt in the comment section? Okay? Okay. Moving on to the next question. Now we have come to the last part. This is what numericals are here. Okay. Now let's study it very carefully. You can do it at the starting of the paper as well if you want, at the end as well. But make sure you read it very carefully. All the numericals, underline it, write down the main things. Let's see. In a parallel plate capacitor, so we are given what? In a parallel, we are given parallel plate capacitors with air between the plates. Each plate has an area of 4 centimeter square. Whatever you are given, write it down. 4 centimeter square. And distance between the plate is 2 mm. Correct? It is 2 mm. What we need to find, calculate the capacitance of the capacitor. We need to find first the capacitance. Now for parallel plate capacitor, I know the capacitance of parallel plate capacitor will be what? It will be epsilon naught A divided by D. Correct? It will be epsilon naught A divided by D. Let me convert this into meter first. This will be 4 into 10 raised to power minus 4 meter square, and this will be 2 into 10 raised to power minus 3 meters. Correct? You just have to put everything here. You are given epsilon naught as well. Just put it here and your C will come out to be 8.854 into 10 raised to power minus 12 divided by area is what? 4 into 10 raised to power minus 2 meter square divided by 2 into 10 raised to power minus 3. You can just cut it and you can just multiply this. You will get C. Let me just see what will be the C. Okay. The C, the answer of the value of my capacitance will be 1.7708. It will be 1.7708. C will be 1.7708 picofarad. Okay, it will be picofarad. Yes, 1.7708. You can use calculators because you are allowed to use calculators, right? Here we have a little less time, so we'll just do the calculation directly. Okay. Now the second part, this is my A part. The second part, if this capacitor is connected to a 100 volt supply. So we are given, if this capacitor is connected to a 100 volt supply, then find the magnitude of charge on each plate. We need to find the charge. Correct? And the capacitance is what? 1.7708 10 raised to power minus 12 farad. Correct? Now, I know that Q equals to CV. I know this direct formula for capacitor. Correct? So, I'll just use that. I need to find Q. So, this will be 1.7708 10 raised to power minus 12 into this will be what? 100. So Q will be 1.7708 into 10 raised to power minus 10. Okay, so this will be the value of charge. Now what else they have asked us? They have also asked us to calculate the energy stored in that capacitor. Correct? So energy, ma'am, we just know energy can be calculated by half CV square. My C is, I know the value of C, which is 1.7708 into 10 raised to power minus 12 into voltage is 100 and it's a square. So I'll just get around 8.854 into 10 raised to power 9, I guess, minus, what is the answer? Yes, it will be minus 9 joule. Correct? And this is my energy of the capacitor. Hence, the whole numerical is done. Okay, moving on to the next one, 43rd numerical. It says a copper wire of length 50 centimeter, right? Whatever is given, copper wire of length 50 centimeter and diameter as 1 mm carries a current of 3 ampere. It carries a current of 3 ampere. Calculate the current density. I just need to calculate what? Current density, which is J. Now current density will be I divided by A, area. Now this, let me convert this into meters. So this will be 0.5 meter. This will be R, will be what? 0.5 into 10 raised to power minus 3 meter. If I divide it by 2 and then convert mm into meter. Correct? Understood? Now the current is 3 ampere. Area will be pi r square because it's a wire. Now this will be 3 divided by 3.14 into r square will be 0.5 into 10 raised to power minus 3 square, and this calculation you can easily do. It will come out to be nearly 3.8 into 10 raised to power 6 ampere per meter square. This is my J. J is 3.8 10 raised to power 6 ampere per meter square. Correct? Now, in the second part they have asked us drift velocity. How I remember drift velocity was like a song. I equals to NEAVD. Okay? So, current is NEAVD. We need to calculate what? Drift velocity. So drift velocity will be I divided by NEA. Now I by A I also already calculated, which is J, which was what? 3.8 10 raised to power 6. Correct? Divided by N is given. Number density is given, correct, which is 8.5 10 raised to power 8. 8.5 into 10 raised to power 8 into electron. This will be 1.6 10 raised to power minus 19. Although you should remember the value of E, but it's also given in the question. And mostly it will be given in the question. When you solve this, the final answer will be, for you to check, it will be 2.8 into 10 raised to power minus 4 meter per second. Correct? This will be your final answer after solving this. Now they asked us to calculate time taken by the electrons to drift from one end of the wire to the other end. Now the length of wire is also given, which is 0.5 meter. So they have to travel a distance of 0.5 meter. Correct? We need to find the time. We also know the velocity, which is drift velocity, which is 2.8 into 10 raised to power minus 4. So my time will be what? Distance by speed, L by Vd, which is 0.5 divided by 2.8 into 10 raised to power minus 4, which will something be around 1.8 10 raised to power 3. 10 raised to power 3 seconds. Correct? Understood this? This will be my time. Okay? You can calculate this easily. Correct? Let's move on to the next part. I'm guessing there is some problem here. The sign. There will be some problem with the sign. 28. Okay. No. It's fine. Okay. This is 28. Yeah. Now it's fine. Okay. Next question. A resistor, a conductor and a capacitor are connected in series. Okay. With a voltage of 110 volt. It is 110 volt. The frequency is 100 hertz. Correct? And in the circuit, the voltage leads the current by the phase difference is 35 degrees. If the resistance of the resistor is 10 ohm, the resistance of the resistor is 10 ohm, and the sum of inductive reactance and capacitive reactance, the sum of inductive and capacitive reactance is given as 17 ohm. Then calculate the self inductance of the inductor, which is what? L. Correct? Now Ma'am, we are given XL, XC, we are given with the phi as well, R, and we just need to find L. So for L, we need XL, correct? For XL, can I write, you now remember this formula, right? XL minus XC divided by R, correct? So XL minus XC will be what? Tan 35 into R, correct? So XL minus XC, what will be tan 35? Tan 35 will be around 0.7002. Okay, it will be 0.7002 into radius as 10. So this will be radians, sorry, resistance. 7.002 equals to XL minus XC. Now we have two equations. This is also given, right? That's why I'm telling you to write everything now. Okay, so XL plus XC equals to 17 ohm. XL minus XC is what? 7.002. If I add these, this will be 2XL equals to 24.002. So XL will be 12.001. Now I don't need XC, though there is no need to calculate XC. Okay. Now L is what? 2 pi nu into XL, correct? 2 pi nu into, okay, it was the other way around. XL equals to 2 pi nu into L. It was 2 pi nu into L. So 2, of course we know, 3.14. Now ma'am, frequency is also given, right? 100 hertz. So frequency is also given. This is 100 hertz. L we calculated almost 12.001 if you want to write. So if you solve this, your XL will be 0.0191. Yes, 0191 Henry. Correct? Your L. What did I do wrong? Yes, correct. So your, no, there is something wrong. Yes, this, okay. This is not given, this is L. We need to find the L. This is L. This is given as 12.001. 12.001 divided by 2 into 3.14 into 100 will be my L. So L will be what? How much was it? 0.0191 Henry. You know how I understood that there was a mistake? From this SI unit. Okay, so remember, when you write everything down with the steps, write what is given, then the formula, then put the values, calculation and SI units. Keep this tracker in your head. So even in the last step, you'll understand that there is a mistake that I did. Because when I calculated XL unit is not Henry, right? Okay. Next, last question. Find the effective focal length and effective power of combination of a convex lens. What is given? A convex lens of focal length, what? 25 centimeter, and a concave lens of focal length 20 centimeter. Now, what is the first step we do when there is a question of mirrors? We check the sign of focal length. For convex lens, it's correct, it's positive. For concave lens, however, focal length is always negative. Correct? Now, they are asking, is the system converging or diverging? We need to find the effective focal length and the effective power. Let's calculate. This is, let's say, first and second. So, P1 will be what? First, calculate this in turn this into meter. You have to convert this into meter. So this will be 0.25 meter and F2 will be 0.5 meter. Correct? Yes. So what will happen? P1 will be 0.25 and this will be around 1 diopter. P2 will be 1 by 0. It will be 0.5, right? It will be 0.05. So that will be 4 diopter. Correct? 4 diopter or what? This will be, yes, P2. 0.05 diopter. What did I do? Oh, I directly calculated it. Here this will be 0.02 meter. So this will be 0.02 and then this will be 5 diopter. correct? Now the power, we know how we calculate the equivalent power. We calculate the equivalent power by adding those, so that will be P1. P equivalent will be P1 plus P2, which will be 6 diopter, correct? This will be 4 diopter. Okay, sorry. This will be now 9 diopter, correct? Now to calculate equivalent focal length, this will be 1 by P equivalent, that will be 1 by 9, correct? So 1 by 9 will be what? Did I do something wrong? 5 diopter, 4 diopter. Okay. One mistake we did. So in here I forgot the sign. My mistake, sorry. This will be minus 5 diopter. So this will be 4 minus 5. Correct? 4 minus 5, which will be minus 1 diopter. Understood now? I'm really sorry. You remember, you can learn from my mistakes, right? Focal length is negative. So make sure you carry that negative everywhere. So this will be minus 0.02 meter. Correct? And then if you divide it by minus 0.02, it will be minus 5 diopter. Correct? And when you add this, 4 minus 5 will be minus 1 diopter. So my focal length will be what? My focal length equivalent will be 1 by power equivalent will be 1 by minus 1 will be minus 1 meter. Focal length equivalent will be minus 1 meter. Since equivalent focal length is minus 1 meter, that means what? Minus is concave lens, correct? Minus is concave lens, and my concave lens, it's not mirror, it's diverging. I have a diverging lens because of the combination of one convex and one concave lens. I get a final concave lens because of their different powers. Correct? That's it for today's. We are done with the whole sample paper. I hope you guys do your PU2 exams really great. If you have any doubt, comment down. You can join our WhatsApp channel, subscribe the channel for more solutions of model paper that are coming. I'll also come live on Monday for question bank of wave optics. So be ready. Till then, tada, bye bye.